Wow. Hi, everybody. Thanks for coming to Empower, our first conference. I'm so excited to see all of you here in the room today. Today, I'm going to be telling you a bit about the story about how Nylas built a stable and scalable API that is used by dozens of customers to power their applications today. We've been doing this for just about 4 years at this point. And along the way, we've learned a few things here and there that I hope that you'll find useful for those of you that are building APIs and services to help other people get things done. As an overview of what I'm going to cover, I'm going to give you a little bit of brief context about what exactly Nylas does. Then I'll talk a little bit about the technology that powers it. And then the meat we'll be talking about some of the things that we've learned over the last 4 years that I hope that you'll all find useful. So what exactly does Nylas do? The reason that Nylas exists is because email contains so much really valuable data, and yet it's really hard to work with as developers. Email contains things like photos from your sister, event tickets and receipts, personal communications, meeting invitations, and more. But as developers, email is about 40 or 50 years old, and computing has changed a lot in the last 50 years. A lot of different functionality has been added on over the decades, and that's resulted in a lot of complexity. The latest versions of protocols to interact with email came from the late 90s and early 2000s, which means they don't meet the standards that modern developers expect. Developers expect JSON, they expect UTF-8 text, and they expect REST APIs that are consistent and easy to use and contain SDKs that you can use to get started with them really quickly. Email falls far short from meeting this bar. And that's why we built Nylas. Instead of having to build integrations with lots of different protocols in order to connect email accounts to applications, you instead can use one single, simple, easy-to-use integration and get access to email inboxes and all the valuable data within them. Let's talk a little bit about the technology that powers Nylas. For those of you who are engineers in the room, you might be interested to hear a little bit about what tech we're using. So we're a Python shop, and we use a few major libraries that are pretty popular in Python land. We power our API with a REST API library called Flask. We use a library called gEvent to deal with concurrency. And our ORM is a thing called SQL Alchemy. And we also use PyTest. To serve the application, our front-end load balancer is a proxy called HAProxy. And then we serve the application using Nginx and gUnicorn. Our primary data store is MySQL, which we actually manage ourselves with primary replica clusters that we run on EC2. Our application talks to MySQL using a high-performance proxy called ProxySQL. And then we orchestrate our servers using a config management system called Ansible. And then we use Redis for caching and queuing. For those of you who are engineers in the room, when you look at this list, you probably think it's extremely ordinary. And that's entirely the point. When we were getting started building Nylas, we decided that we wanted to spend most of our time and energy figuring out whether or not the API was actually something that people would find useful and get value out of, and also figuring out how to build a business around it. As startups, we don't have time to wake up in the middle of the night because we're using some crazy database that is corrupting data. And if you've ever read Dan McFunley's fantastic essay, Choose Boring Technology, you may have seen this quote. It says, let's say every company gets about 3 innovation tokens. You can spend these however you want, but the supply is fixed for a long while. So we decided not to spend these on our base technology, but instead to spend them figuring out what would make customers' lives easier and make developers happy. In the early days, we also spent a lot of time thinking about what driving principles should lie behind the decisions you were making with how to structure and form the API. And the thing that we kept coming back to was the entire point of building Nylas was that clients and developers should have to build one single integration to power their apps, not 7, which was the status quo. And that meant we spent a lot of time making sure that we could abstract across differences between providers and provide one simple unified email API. In the beginning, when we were trying to figure out how we should actually build the software behind this, we had a few different things that we thought about. The end goal was to provide a consistent, simple, easy to use, and fast API that developers could use to access email data. And there are a few different choices that we could make that could get us there. The first possible strategy was that we could try to sync as little data as possible, and instead, when people make queries to our API, simply proxy them to upstream providers like Google or Microsoft. Or we could do something a bit more aggressive, and we could actually sync and mirror the contents of the email inboxes into our data store so that we could serve most queries without ever having to talk to the upstream providers. And so we were thinking about these different strategies, and we went back to what our end goals were. And that was to provide a fast and simple and easy to use API that people could use instead of talking to upstream providers. And this meant that we had to choose the second strategy. Proxying, while cheap, has a number of different disadvantages. One, it adds a lot of latency to each API request because you have to open another request within the request to talk to your upstream provider. Plus, we didn't want to be limited to the constraints of what things were easy to query with the existing APIs, which meant that we didn't want to have to compose different queries to the upstream providers and pull data together in order to serve simple API queries. We also needed our API to be really reliable so that folks could use it instead of upstream providers. And if you're proxying, that means that your reliability is the product, actually, of your software's uptime, plus the reliability of the network link that you're using, plus the reliability of the upstream email providers. And those providers do have outages. We've seen Microsoft outages over the last few years. We've seen Google outages. And we didn't think that met our bar for quality. So we had to go with the second option and figure out how to make the business work around that, even though it costs more. Here's a rough outline of what our application architecture looks like. It's actually pretty simple. We essentially have two major fleets of servers that do most of the work, and one primary data store, which is MySQL. We have a fleet of servers that runs and serves our API, so it's serving hundreds of requests per second as clients ask for data and ask to move it and change it. And then we have a fleet of servers that actually runs behind the scenes and is continuously syncing email mailboxes and keeping our data store up to date. We also have a front-end proxy that load balances the API. And we use Redis for doing some caching and queuing behind the scenes. This architecture is really not very complicated, and there's a reason for that as well. The reason for that is really that we wanted to spend as much time as possible figuring out the product and the business. Making the application architecture more complicated before you need to means that you'll just spend more time figuring out how to operate it. So let's dive more into the lessons that we've learned from building this product. The first one, which I've already mentioned, is to, and I'm repeating it here because I think it's really important, is to use boring technology and to not get hung up on using the most cutting-edge thing. The importance of using stable building blocks really varies depending on which part of your application that you're building. But things like databases, for example, it's really important to use something that's battle tested. The second part of this is to not use microservices until you need them. And if you have one engineering team that's building one product, you probably don't need them yet. If you start using microservices before you need them, you'll have to invest a ton in operational infrastructure in order to be able to maintain these well. And it also makes debugging more complicated. We've synced and served over 10 billion emails, and we still haven't broken our service down into a complete microservice architecture. It's on the horizon, and we know it'll happen eventually, but no need to over-engineer things before it's needed. The third thing I want to talk about is how open source is an important part of building developer trust. When we launched the Nylas API, the first thing we actually launched was not a running service that you could use to power your application. It was a code repository that we released on GitHub. And we were actually really terrified to release our code publicly on GitHub because we were afraid that people might look at it and criticize it or steal it and copy us. But it turned out that, looking back in retrospect, this was a really powerful decision that really impacted our growth and helped us get off the ground. A lot of folks don't release any server code for their products. They'll release client SDKs that folks need to build into their applications to use them. But when it comes to understanding how the backend works, developers are essentially left in the dark. And in the beginning, when you're trying to get people to use your product to build their applications, there's a lot of trust that you have to build. And one way to build developer trust is to show them the source code. People are taking a big risk by building their applications on top of a new platform, and they know that. So you need to work extra hard to get over that hump, especially in the beginning. By putting our source code out there and saying, well, if we go away as a company, you folks can take our code and continue to maintain it and run it yourselves. We got over that initial hump of building developer trust. And that was really important for getting us to the place that we are today. The fourth thing I want to talk about is it's really important to be consistent in your API. And what I mean by this is it's a couple of things. One, if you have many different APIs that serve different data, you should use the same structure for all of those different APIs. One of the advantages of Nylas over, for example, upstream providers' APIs is that you can access email and contacts and calendar data all with the same simple structure because it was built and designed by the same team. Consistency makes it much easier to get started and to be able to use different parts of an API while having learned only one part of the API, because you can expect that the other parts will work in the same way as the parts that you've already worked with, which makes the learning barrier a lot lower. And it's also important not to break your API. And what I mean by this is when you release new features or release bug fixes, folks have taken a big risk building their application on top of your platform. And they need to trust you to not break their application when you're changing your API platform. There's a number of different things that we've kind of figured out over the years about how to do this. And one is, for example, when you're building a new API, it's really important to move fast and iterate, right? That's how you do good agile development practices. But that's at odds with this idea that when you release something and people start building on top of it, you can't really change it. So we worked around this by doing things like writing the API docs in spec first and sharing those with the interested customers or people that have opted into a beta of a certain feature in order to get feedback really rapidly, even before we've started building any code. Then when we actually build the first version of a new feature or an API, we will often not publicly document it until we've validated that feature with some actual customers who are going to be building on top of it and using it. And these two simple strategies have allowed us to reduce the number of things that are weird or inconsistent or kind of broken that need to be fixed later. There's also strategies that you can use to deal with inconsistent changes that you need to do. Like, for example, Stripe uses this strategy called gating, in which you actually pin clients to certain versions of your API, and as you introduce breaking changes, you allow them to upgrade versions, but leave in the code the old logic so that you can still serve the version that old clients expect. And this is a totally valid and useful strategy, but it's also important to minimize doing that in the first place, because maintaining all of these different code paths to serve different versions of your API adds up to more maintenance burden over time. Another thing that we found is really useful is that documentation is great, but documentation that helps you build your app is even better. Developers love being hands-on and being able to run things really quickly. And if your developer documentation does things like gives you code snippets that you can run, generates the right curl request that you can copy and paste into your terminal and run and see it in action, gives people a much more tangible understanding of your API and how it works, and also helps developers get off the ground much more quickly. It's easier to go from a code snippet that basically does the gist of the right thing that you want to do and modify that to plug it into your app than it is to start from scratch, starting just from documentation. There's even SaaS services out there that can help you build these kind of docs really easily. We use a product called README, and it's been really helpful for us in terms of providing better documentation for developers. Number 7, have a status page. Now we're going to talk a bit about reliability, which is another really important piece of having developers and companies trust you. If your app is down, some part of their app is down. And it's impossible to have an API that's never down, but it is possible to have very good uptime. And it's also really important that when you are having issues, that you communicate them really well to people that depend on your service. We use a SaaS service called statuspage.io for our status page. So you don't even have to do a whole ton of work to get a status page for your service. There are also folks out there who build their own bespoke versions, but you don't have to. And a lot of us don't have the time, so we can just use a service that gives us a status page out of the box. Number 8, availability and uptime is great, but it's only the foundation of reliability and trust. If your API is up all of the time, but your customers are running into issues where there are like bugs and it's not doing what they want, then essentially to them, your product is down. So it's really important to think of reliability holistically, both in terms of whether the service is up and responding to requests, like what the success rate is of requests that you're serving, how many 500s are you serving, how many errors are you recording on the application, and also to be able to think about reliability as actually powering people's applications well. To do this, you need instrumentation and monitoring. When you're a platform, you need to be able to drill into the metrics behind your API and visualize what exactly a customer is actually experiencing from the point of view of their application. We use a few different tools to do this, and the most important one is this thing called Honeycomb. If you have ever worked at Facebook or have read a Facebook paper called the Scuba paper, this kind of tool might be familiar to you. And what Honeycomb allows us to do is we basically pipe a feed of logs and events to it. And this includes the logs of what requests we're serving. And we can tag these API requests with all sorts of different information. The whole point of this tool is that you can add an arbitrary number of fields, and then you can query and analyze based on those fields. So one thing that we ship to Honeycomb is, for example, the ID of which application made a request. So when we're investigating issues for a particular customer, we can go to Honeycomb and pull up exactly which requests they've been using, see the latency of those requests, see any errors, and see what it looks like from their perspective so that we can make sure that they are being successful. We also use more traditional monitoring and metrics tools. This is a screenshot from one of our dashboards just for checking out system status. And these are also an important part of instrumenting your API, which a lot of folks may be more familiar with because you need these even if you're not running a platform. But when you're investigating issues, you may start with something like Honeycomb where you can dive in and figure out where the problem is coming from. And then you might need to fall back on things like traditional metrics in order to debug systems issues. The last thing I wanted to talk about is really the human element. At the end of the day, we're all building products and services that are about helping other people get something done better and faster and with fewer resources than they have. Together, we can help people build things that they wouldn't be able to build before. And that's what motivates me at the end of the day. None of the things that we're building are necessarily rocket science, but no one has enough people and time to build everything themselves. And that's why SaaS is taking off. That's why it's important, and that's why we're having this conference. So thanks you all for coming.
Thank you again. That was awesome. Does anyone have any follow-up questions for her? And we have some mic runners who will bring the mics back to you.
Hi, so we're a small SaaS company, and we've just released the first version of our API. And I noticed that you were talking about keeping an API stable and not breaking that API. And we're getting a lot of requests from customers to add new features to the API. And we're wondering, how do you balance the need to add new features and grow the ability of the API really quickly without breaking things? And I feel like if we made all the changes that people ask for, there'll need to be a lot of change in future versions.
Yeah, there's a couple things I would think about here. One is talk to a lot of your customers and validate those ideas on other customers, because if you're building a platform, it's really important to make sure that things that you're committing to support are things that you're not going to be building just for one single customer. Sometimes that can be appropriate if it's a really important customer, but in general you should be managing your roadmap by having regular customer conversations, taking ideas, validating them. And then I would go back to the things that I actually mentioned in the talk, which is for changes and new features that you are going to build, write the API spec, run it by your customer, and then don't publicly document it until you're sure that it works for them at least. And then in the long run, you'll want to look into something like having some sort of versioning on your API. It's impossible to predict the future, but you can do some upfront investment that will kind of reduce the risk. And I think it really comes down to communicating a lot with the people that are going to be using your product. Any other questions?
Sure. So my question is a bit related, but it's more about the aspect of releasing your source code on GitHub and basically balancing your willingness to open your code versus now you have also to maintain it for all the developer communities. They're going to come back to you with questions and how did that work? How can we improve this one? Do you invest much of your time in maintaining that, or once you just release it, it's done? It's a done deal and it's out the door.
Yeah, for sure. For our server-side code, I have to say that we've gotten a lot of value out of just releasing it and haven't spent much effort in trying to build a community around it, which is, there are companies out there that do like invest a lot of time and energy in doing that. But for server-side code, it's actually really tricky to do that because, for example, in the early days, we had things like people are being like, well, I want to run this using Postgres, and it's like completely not a good use of our time to like modify our code to support multiple databases. And so we pretty much decided that like for stuff like that, we would tell them to fork it and maintain it on their own. So I think the main uses that we've seen, there are some people that do like take our code and run it themselves. But we also have customers that will, because email is a very heterogeneous ecosystem and there are like kind of weird edge cases and things that can go wrong, some customers of ours actually use our source code when like our dashboard is showing them that some account is having like a sync error and they're trying to figure out what that means. So I think for a lot of folks, like spending a ton of time building a community is not necessarily a great use of their time. Any other questions? Yeah.
Oh, there you go.
Yeah, so you mentioned that you sync emails from all the providers to your servers. Do you also do that with calendars? Because like I know a lot of calendar APIs don't give you like webhooks when new events get added. So I'm curious how you manage that.
Yeah, we do the same thing for contacts and calendars, and it's actually a lot simpler for contacts and calendars because it's like an order of magnitude less data. So it's like less expensive for us to run and just easier to manage. But there wasn't really a reason for us to consider a different strategy for that, especially since it's like an easier problem overall. And we solved the email problem first, and it's like, well, we'll just do the same thing for calendars. Great. Well, thanks again for listening to my talk and for showing up.